In our today's mathematics class, we are going to look at decimals and percentages. As earlier on seen in our previous class, we have been able to relate or to connect percentages with fractions and decimals. Just as we saw earlier on that sometimes we should be able to use what we call memorized number facts to get what we want to find. For example, if you have this question, convert the following fractions to decimal and percentages. And the one is 17/10. And 2 is 9. Nine quarters. Now we have this. We want to convert 17/10 and 9 quarters into decimal and percentages. In our solution, taking the first one, we find that we shall be required to understand what a tenth simply means. And a tenth in this particular case is 1/10. So we need to understand that 1/10 is a tenth. And as a percentage will be 10/100. So 10/100 is an equivalent fraction of 1/10, which is the same as 0.1. Or simply we say is the same as 10%. Then it follows that for 17/10, it is the same as 17/10. When you look at 17/10, it is an equivalent fraction because we want to make the denominator 100. So we shall multiply here by 10 to be 170, and the denominator multiplied by 10 to be 100. And this one will give us what we have as 1.7 as a decimal. And when you move into a percentage, you'll find that this one is 170%. 170%. Why are we saying that this is the case? This is what we were looking for. Now, we should first memorize what we call number facts, which is this one here. And then having memorized that, we multiply by 17 because we have been asked for 17/10. That's what we arrive at, 17/10. Make the denominator 100 by multiplying by 10. We have 1.7 as a decimal and 170 as our percentage. For the second part, 9 quarters, for 9 quarters, now our memory fact about that is to understand what a quarter means in this particular case. And a quarter is 1/4 which implies that that is our memory fact, and when we make an equivalent fraction with the denominator as 100, we shall multiply this one by 25 and the denominator by 25 to get 100. Now this one as a decimal, it is 0.25, which is the same as 25%. But that is not what we are looking for. What we are looking for is 9 quarters, which means we take the memory fact of a quarter multiplied by 9, so we shall have 9 over 4. So we've been able to multiply this by 9 to get what we have as 9 over 4. So what follows for the second part here, then it will mean that we need to multiply across. And when you multiply across, you'll get 9 times 25. You'll get 225, and this one will be 100. This part here is not that necessary. And why I say it's not that necessary is because we already have the percentage, the decimal for the memory fact. So we can simply take 9 multiplied by 0.25, which will get 2.25. This is the decimal. And then finally, as a percentage, it is 225%. It is 225%. So this is how we use memory fact to convert a fraction into decimal and percentages, respectively. Let us now look at the decimal and percentage conversions. Decimal and percentages conversion. Now, earlier on, we noticed that percentages are commonly used in today's society. And here we find that given an idea of proportion, it cannot correctly give us the details of what fraction or what percentage is required. That's why we convert the proportion we have into percentage. Then it is easier to know to compare the values. Let us look, for example, if you happen to wake up one morning and you find that in one of the villages we have 2,000 people who want the government to construct a swimming pool. These people, 2,000, requires a swimming pool. They require a swimming pool. Now, you notice that it is not telling us what fraction of these people the 2,000 is. Could it be on the higher side? Could it be on the lower side? We only know of the numbers. But if we move ahead and say in the village of, so the total number of people in the village maybe is 2,500 people living in this village. Then we shall find the proportion that 2,000 of the 2,500 people are interested in construction of a swimming pool. We need now to come up and see. This is 2,000 of the 2,500. This one can now be simplified, and this is equivalent to 20 over 25. So multiply by 4, you find it's 80 over 100, which is equivalent to 80%. So we can comfortably say that 80% of the people in that village requires a swimming pool. The percentage is giving us if at all the population is on the higher side or it is on the lower side. So as earlier seen about the percentage, we realize that the symbol that we use is this way, that this symbol here means percent. And I said earlier on, it's a word that comes from a Latin word, percentum, which translates to out of 100. Now, let us look, for example, when we have 23%. Remember, it's about conversion. When we have 23%, this is the same as saying, this is the same as 23 out of 100 or 23 over 100. So if we were to convert this percentage into a fraction, we would stop there. If we were to convert it further into decimal, then we would find that this one is 23 hundredths, which is 0.23. So in this particular case, you find, given a percentage, we can convert into a fraction or further into a decimal. You notice that to convert a percentage into a decimal, you simply need to divide by 100. That's what is here. 23 divided by 100, that is what you simply get. You simply need to divide by 100. And this is simply done by moving the decimal point 2 places to the left. Let us see. 23 over 100. I'm saying this is done by simply moving the decimal point 2 places. This is 100, so 2 places to the left. So you find that for this particular case, if we have, this is the same as 23 divided by 100, which is now 23. We want to see how we shall move the decimal places. So this was the original. This is where we have the decimal point at the moment because it's a whole number. This is 1, this is 2. So we shall come to this particular point and define the answer is 0.23 as a decimal. To convert a decimal to a percentage, we simply multiply by 100. And this is done by moving the decimal point from where it is 2 places to the right. Let us see about that. So you are saying, when you are converting a decimal point, a decimal into a percentage, you are required to multiply that decimal by 100. So you multiply by 100. For example, convert 0. Let us look at 0.654. This is a decimal. We are required to convert this decimal into a percent. As said here, we only need to multiply by 100. So it will be taken as 0.654 times 100. And as we are multiplying, it is very simplified in this particular case because this time round, we only require to move the decimal point. There are two times to the right. So this is 1 here, the second one is between 5 and 4. So you find that you'll have 65.4%. 65.4%. So a decimal into a percentage, you only require to multiply. Let us look at these examples. Express the following percentages as decimals. And we have 30%, and B, we have 240%. Let us have a C, which is 0.4%. So we are to convert this in our solution, starting with 30%. Just as said earlier on, if we want to convert a percentage into a decimal, you only require to take it and express it first as a fraction. Then you realize that it is the same as taking that number and dividing by 100. So if you rewrite 30%, what you'll notice is that 30% is the same as 30 over 100, which is 30 divided by 100. We only require to move the decimal point to the left. Because it is 100, so we shall move 2 spaces. So from here, this is the first one, this is the second one. So we shall have a decimal point there. So our answer becomes 0.3 as a decimal, 0.3. Therefore, 30% is the same as 0.3. Coming to 240%. As seen earlier on, it is equivalent to 240 divided by 100, which is 240 divided by 100. Let us see the number of decimal spaces we are going to move from a whole. This is the first one, this is the second one. So we shall stop at 2.4. So you'll find that your answer as a decimal is 2.4 as our answer or as our decimal. So to convert 240% into a decimal, you simply need to divide, and that's what we get, 2.4. You notice that from 240 we moved 2 spaces towards there. We moved a decimal point 2 points or places towards the left. The last one of 0.4%, 0.4%, to convert this, it is equivalent as simply saying 0.4 divided by 100, which is 0.4 divided by 100. We need to move the decimal point, and the decimal point is here. So the first one comes this point. We need to move again the second time, and the second time we move, we shall create a 0 here so that we can get a decimal point there. So you find that this is being reduced to be 0.004. This is what we shall have as a decimal. So you find it is already correct to 3 decimal places. So we can simply convert any decimal, any percentage into a decimal. Now, let us look at the other way on questions that now we can convert decimals into fractions. This one was converting decimals into percentages. This one was percentages into decimals. Express the following decimals as percentages. And this one we have 0.045, and then B we have 7.2. So we have those two, 0.045 and 7.2. In our solution, from the question we are required to convert or to express the two decimals here as percentages. And as we saw earlier on, if you can remember, we say that to convert a decimal into a percentage is simply multiplying it by 100. And while multiplying by 100, the decimal point this time round moves to the right. Because you are multiplying by 100, it will move 2 steps. So let us start from the first one. 0.045, this is a decimal. To convert into a percentage, we shall be required to multiply by 100. And as said earlier on in our introduction, to do this, we need to move the decimal point 2 steps. So the decimal point will move from here to that place there, and therefore our answer will be 4.5%. Remember, you must indicate percent so that you can be sure what you are looking for is a percentage. So note that the decimal point moves 2 places to the right when you are multiplying by 100. We have 7.2, and to convert this into percentage, we shall multiply by 100. We shall multiply by 100. As seen earlier on, even from this previous example, we notice that the decimal place is very important when converting, where it has to move to the right 2 places. So the first place it moves, it will give us 72. The second place it moves, we don't have a figure, we shall put a 0, so it moves and leaves us with 720%. So 7.2 is equivalent to 720%. Let us now look at fractions and percentage conversions. Fraction and percentage conversions. Now, we notice that just the way we saw earlier on, percentages being the most common ratings or comparison that we come across in our daily lives, the interest rates, the discounts we have, the test results, and statistics, all of them mostly expressed as percentages. So then it is necessary that, because the common way of expressing this is dealing with percentages, then percentages, you'll notice that they are closely related to fractions. Remember earlier on when you were introducing, we said a percentage is equivalent to saying out of 100. It's simply a fraction whose denominator is 100. That is, for example, if somebody tells you 87%, you are saying percentage is closely related to fraction because this simply means 87 out of 100, or 87 over 100. Already we have a fraction. That's why we are saying percentages are closely related to fractions. Now, sometimes when everything is in form of fractions and then we want to start rating or ranking this, it could be hard until we require to bring them into fraction. Let us consider a simple experiment here and see how the difficulty it will bring when we are trying to see or rate these students. Now, in a class of mathematics, we have got several students scoring different marks in different papers. We have, so in a mathematics class, we have Matthew, we have Magna, we have Maria, Marcus, and Melissa. Now, these students, Matthew scored 15 out of possible 20 marks. Magna scored 36 out of the possible 50 marks. Maria scored 33 out of possible 40 marks. Marcus scored 7 out of possible 10 marks. And finally, Melissa scored 64 out of possible, we have 80 marks. So in other words, we can simply agree and say that Matthew scored 15 over 20. Magna scored 36 out of 50. Maria is 33 out of 40. Marcus is 7 out of 10. And finally, Melissa is 64 out of 80. Now, what I want you to notice here is this. To come up with a ranking until we say that this one performs better than the other one becomes a bit complicated, because all these fractions have got their own different denominators, and at any given time they are just different. So, but the simplest way, if we are able to convert a fraction into a percentage, then things will be very simple. Take note that for us to do this, we only need to maintain a denominator that is 100. So we can still rank these pupils here by simply bringing them now to the denominator of 100. And this can be done in a very simple way, and from there we shall now be able to identify who is leading and who is not. As you will go about doing that, you realize some areas it is very simple, some areas it is very difficult. But by the end of this lesson, you'll have found an alternative way of solving such a problem. It is still easy. As we said earlier on, it is very important to always simplify your fraction to the simplest form possible. But for this particular case, we need to come up with the equivalent fraction of close to, with a denominator of 100. So for the first one here, this, when we multiply the numerator by 5 and down by 5, you'll get Matthew will be scoring 75 over 100, which is 75%. This one is just multiplied by 2, so this one will give us 72%. For Maria, I'll leave it out first, and then as we come back to it. But for Marcus, it is multiplied by 10, so this is equivalent to 70%. Now, for Maria and Melissa, this requires a bit of attention, just the way we shall look at it in a few minutes. You realize that this and this may require you to do quite a lot of division, or alternatively, you only need to pick a calculator and you punch in, and after that you have your answer, because it is a division that we require while we are doing this. So the very first thing here, when you key in using a calculator, it will automatically give you a decimal. And to change from a decimal into percentage, you only need to multiply by 100 and move the decimal places, 2 places to the right. So for 33, you find 33 over 40, if you're using your calculator, you'll find that this is 0.825. As a percentage, we only require to multiply this by 100 or move the decimal point twice to the right, and you find what you get here is 82.5%. We have Melissa's case. In Melissa's case, we find that it is 64 over 80. This one gives us 0.8, which is equivalent to 80%. Now we are done. We can start rating these students and identify who leads where. We have Matthew with 75, Magna with 72, Maria with 82.5, Marcus with 70, and Melissa with 80. From the look of things, you realize that the student who is leading is the one with 82.5, followed closely by one with 80. This is at portion 2. From there, we move to the one with 75, and for 75, we have Matthew at portion 3, and then we are remaining with 72 and 70, so Menegda comes second last, and lastly we have Marcus at portion 5. Now you realize that it has been easy to rank them, having changed everything into percentages. So let us look at the approach we give as we convert fractions into percentages. Now, the first thing we need to do, take note of it, we can simply write percentages as fractions by simply changing the sign. And the sign we are talking about is this sign. By simply changing that sign and substituting with a denominator of 100. For example, if we were having 22%, we are removing the sign and substituting it with out of 100. So already we have a fraction. At the same time, we can also convert fractions to percentages through the knowledge of equivalent fractions. But this one, when you are talking about equivalent fractions, for percentages, we shall not look at all, but we shall be looking that to numbers that are possible. So this idea works well when the denominator is either 2, 4, 5, or 10, 20, 25, and 50. The idea of equivalent fractions, where we shall reduce the denominator to give us, 100, works very well when we have the numbers like the ones I've written on board. So you'll notice that from our previous example, where we were required to go further, we had a number which was giving us the denominator as 8. That one was a bit different. That's why we went to the calculator. It's not among this one. But for this one, you can simply get the equivalent fraction without any problem. Take, for example, if you have a quarter and you want to convert into a percentage, this one will not be a big issue because we find a number that will give us an equivalent fraction but with the denominator of 100. So we multiply the denominator by 25, you get 100. The numerator by 25, you get 25. So this one is equivalent to 25%. Other denominators which are not these ones might be a bit difficult. Let us look at those ones. Other denominators other than the ones we've just listed above, for example, 3/8. This is a fraction. To convert this using equivalent fraction may be a bit difficult. Let us see. First, we need to make a denominator 100, but you realize that 100 is not a multiple of 8. Therefore, it is not possible for us to have a denominator of 100. So what happens? We move to the next step. You realize that 1000 is a multiple of 8, which means 8 multiplied by 125 will give us 1000. So we shall take 125 and multiply the numerator also by 125. So what you get here is 1000 and not 100. At the numerator there, what we get there is 375. Now, this is that, but it is not a percentage. The question requires us to convert this into percentage. Then we shall be required to bring in the decimal behavior first, then we move ahead and find the percentage. Or alternatively, we divide by 10 so that we remain with 100 as the denominator. And if we divide this by 10, we should mean that we move one decimal, one place to the left and one place to the left, so we remain with 37.5 over 100. Once the denominator is 100, then the figure above represents the percentage that we require, which is at 7.5%. As I was saying, once the denominator is not among those lists that I gave earlier on, the 2, 4, 5, 10, 20, 25, 50, and 100, then it might be a bit difficult. That's why this sum has pushed us further to an extra mile. So it is necessary that we should be able to find the common or the equivalent fraction irrespective of the denominator. But take note that the denominator we went for is still taking 100 as one of its factors. That's why we have 1000 there. So this is how we were supposed to approach that. Now let us look at the common percentages and their equivalent fractions. These are just common ones. You meet them every day. You don't need to struggle while you want to convert some. So we shall have two rows. We have fractions and we have percentages. So we're not looking at all, just a few. When you are given a half, definitely this is not something to think about. A half is equivalent to 0.5, which is equivalent to 50%. When you are given a third, this one is equivalent to 33. I write it as a mixed numeral, and a third percent. I have not said 0.3 because we are talking about fractions here. When we have a quarter, this is equivalent to 25%. Then we have a fifth. This is equivalent to 20%. We have an eighth. An eighth is equivalent to 12 and 1/2%. We have 2/3. When you have 2/3, this one is equivalent to 66 and 2/3. And lastly, 3/4, that is 3/4, is equivalent to 75%. These are just a few that we call percentages that are common with their equivalent fractions. So let us now look at the questions and how well we are supposed to approach those questions. So first, we are going to look at converting percentages into fractions. Converting percentages into fraction. Express these percentages as fractions or mixed numerals. And the first one we have is 17%, B 36%, and C 176%. Sorry, we have 140%. That's 6. So that is what we have. How do we tackle this? As I said earlier on, that percentage is closely related to fractions. So for this particular case, there's nothing complicated because 17% is the same as 17 out of 100, which is the same as 17 over 100. Now, simplify where possible. 17 is a prime number. It has got only 2 factors. So it's not a multiple of 100. So the answer remains 17 over 100. So this is a fraction on its own already. Second part, it is 36%, which is the same as 36 out of 100, which is 36 over 100. We look at the highest common factor that exists between the two, and we do what? We do simplify. And you'll find that this is, let us use mental case. This is the same as 9 times 4 gives us that 6. This is the same as 25 times 4. So which means that the highest common factor that we have here is 4. So when 4 cancels with the other one here, we shall remain with 9 over 25. This one is in its simplest form. So we can simply agree that 6% is equivalent to 9 over 25. 9 over 25. We are remaining with 140. Let us look at 140%. 140% is the same as 140 out of 100. Out of 100, which is 140 over 100. Now again, just like the other one, look at what is common between the two. The highest common factor between 140 and 100. You realize this is the same as 7 times 20, and down here is 5 times 20. So 20 is the highest common factor. And in that particular case, I'll simplify. I'll cancel out 20 so that I remain with 7 over 5. Actually, this is already the answer. I can leave it as an improper fraction, or as a mixed numeral, which will mean it is 1 and 2 over 5. 1 and 2 over 5. That is if we are to give the answer as a mixed numeral. For the last question, where we shall look at percentages to the equivalent fractions, convert the following fractions to percentages. Convert the following fractions into percentages. One, we have 5 over 100. B, we have 11 over 25. And C, we have 5 over 8. D, we have 3 and 3 over 5. So in our solution, we shall handle each one independently. We have the first one is 5 over 100. Now this is already a percentage on its own because the denominator is 100. And if the denominator is 100, this is simply equal to 5%. We are done with the first question. Second question is asking us to convert 11 over 25. So for 11 over 25, we need to come up with the equivalent fraction whose denominator will be 100. So what do we need? What do we need to multiply 25 to get 100? You'll get 100 by 25 is 4. So multiply here by 4, multiply here by 4. You'll get this one is 44. So 44 over 100 is equivalent to 11 over 25. Because the denominator here is already 100, then we say the required percentage here is 44%. You can simply agree that 11 over 25 is the same as 44%. That is done. The second one. The third, where we said we require additional knowledge, we have to convert 5 over 8 as a percentage. As we saw earlier on, 8, for 8, 100 is not one of the multiples of 8. Therefore, we need to go extra smart. So we go for another denominator which can be a multiple of 100. So this one will give us what? You'll find that we shall multiply 5 by 125 and denominator 8 by 125 to get, and when you multiply that, you'll find that you have 625 over 1,000. So we cannot say this is 625% because the denominator is not 100. The denominator is 1,000. So we shall divide by 10, and if we divide by 10, we shall move to the left 1 decimal point and stop there. So you see, we have now 62.5 over 100. If we have 100, that is already a percentage. We can agree and say this is 62.5%. And finally, we have a mixed numeral, which was 3 and 3 over 5. Now this one, we have two ways. First, change it into improper fraction, which is 3 times 5, which is 15. 15 plus 3 gives us 18 over 5. Now write an equivalent fraction whose denominator will be 100. You'll find that we shall multiply this one by 20. That will give us 100. I want to believe so. Multiply the numerator by 20. So when you multiply the numerator by 20, you'll get something like 360. Now, when you get 360, we are dividing by 100. Then automatically, 100 is a denominator. It is already telling us the percentage. Therefore, this one is 360%. 360%. So that is how we normally handle the conversion of percentages to fractions, percentages to decimals, decimals to fractions, and fractions to percentages. Thank you for listening.